Now that I've gone through some of the different scan methods you might use to acquire 3D data and the different data types, I want to talk a little bit about the process you would use to uh, create usable 3D data for analyses. So, generally, as I said before, you're going to want a mesh for pretty much any analysis you're going to do. If you do a surface scan, this will generate the mesh directly, so all you'll be left to do is clean the mesh. However, if you do a CT scan, you'll need to take a couple extra steps to create a mesh that's usable for other analyses. In these demos, I will be using a program called 3D Slicer to do this. The first step would just be to visualize the volume, which you can do by looking at the different slice views of the volume, which will basically just show you different cuts through the specimen. And the other thing you can do is volume rendering, as I showed in the previous video, to get an idea of what the specimen looks like as a whole. Next, you want to crop to your specific specimen of interest, since many CT scans will contain multiple pieces because it's more efficient to scan that way. As you can see here, my scan of the Creodont patriofelis contains many different elements of that fossil, but if I'm interested in just the skull, I want to crop to the skull. Finally, you'll want to segment the area or the structures of interest in order to generate the mesh. So in this picture, you can see everything I've marked in green is the skull, which is the structure of interest that I want to create a model of. The inside part of the skull that's gray, that's not marked, is the rock matrix, which I don't want included in this model. And the outside black part would be the air, which I also don't want to include this model. Slicer isn't the only tool available for CT data processing, and in fact there are quite a few other free and open source tools you could test out. Slicer was originally designed for medical CT research, so many of its tools are designed specifically for that. However, it has become much more broadly applicable. It can use many different data types, and many different extensions have been developed for it, which gives it lots of different functionality. This is why I prefer it over the other options I have listed. The one downside of Slicer is that it requires a lot of RAM or computer memory in order to use correctly. So if you don't have access to a powerful computer, that's when you might want to start looking to, I would say, either Spears, which is paleontology specific, or Drishti, which is a more general CT viewing and processing application. ParaViewer is a very broad 3D data viewing application and processing, and as far as I've looked into it, it seems like the learning curve is quite steep, so unless you have much more complex analyses going on, I would not recommend starting off with it. Finally, ImageJ, or Fiji, which stands for Fiji is just ImageJ, is not going to generate meshes from your volumes, but it can be really good for converting formats. So, for instance, you might want to convert a stack of images, like bitmaps or JPEGs, into a single NRRD, or even downsample your images if you're using Slicer and it's taking up too much memory. On the commercial side, programs like Amira and Aviso are definitely going to be more user-friendly and maybe have a bit more functionality than this free software. However, they are extremely expensive, which is why I do recommend starting out on the free software.